I'd like to make a correction to the previous slide that I discussed in the earlier lecture. I was referring to this red line when I was talking about rainfall. However, it's the blue area down below here that represents the rainfall. So in this diagram, you can see that in a tropical desert, the rainfall is depicted as less than 50 millimeters per month. And in a temperate desert, it's actually looking like they're getting more rainfall than a tropical desert. And then here, the cold desert as well. Still, they're receiving more consistent rainfall throughout the year. There are three major types of grasslands that are listed on your screen: the tropical, temperate, and cold again. We have this three category for forests, grasslands, and deserts. And we call a tropical grassland a savanna, a temperate grassland is called prairie, and a cold grassland is called tundra. And there's a presence of soils that remain permanently frozen, or permafrost, throughout the year. This graphic depicts the comparison of temperature and rainfall over time for each of these categories of grasslands. So in a tropical savanna, the temperature remains consistent throughout the year at about 20 degrees Celsius. In a temperate grassland, the temperature will dip below freezing during the winter and the spring, but then rise to a level of about 30 degrees Celsius, which is warmer than what we see in the tropical grassland. The cold grassland is going to have a lower peak temperature and drop further below freezing in the cold grasslands known as like the Arctic tundra. Now, the blue shaded area represents the rainfall in each of these types of grasslands. So the tropical grassland gets a good bit of rainfall, about 125 millimeters per month, primarily during the spring and the winter, and the rainfall decreases during the summer months. The temperate grassland receives more rainfall and goes up and down over the summer months and trails off during the winter. And then the cold grassland, out of all three of these, receives the least amount of rainfall. The pictures that are shown depict different types of grasslands, and the top one being the tropical savanna, that is located in Masai Mara National Park in Kenya, Africa, and there's wildebeest grazing there in that picture. The center photo is a picture of East Glacier Park in Montana, and I've been to this area and have pictures similar to this with the wildflowers blooming, and it's absolutely beautiful. So if you ever get a chance to go, I'd highly recommend it. And the bottom picture is of Alaska with the Alaskan mountain range in the background, and this is a picture of the Arctic tundra. There are three major types of forest: the tropical, temperate, and cold category again. The tropical is going to be found near the equator. The temperate consists primarily of both deciduous trees and coniferous trees, and the cold is going to consist only of coniferous trees, and it's found at higher latitudes as well as higher elevations. This diagram depicts the comparison of temperature and rainfall over time for each category of forests. You'll notice that the tropical rainforest temperature stays consistent throughout the year. The temperature, at about 25 degrees Celsius. The, again, temperature of the deciduous forest will rise up above the 25 degrees Celsius, but always trails off during the winter and the spring. This is typical to the temperatures that we experience here in Pennsylvania. And then the evergreen coniferous forest will actually get colder than what is experienced in the temperate deciduous forest and will drop further below freezing in those zones. As far as rainfall is concerned, the tropical rainforest, in comparison to all the biomes, gets the most amount of rain, up to about 250 millimeters per month of rainfall. The rainfall in the temperate deciduous forest is less than the tropical, but fairly consistent throughout the year, with an average rainfall of around 125 millimeters per month. And then less rainfall is going to occur in the cold forests, or the boreal forest or taiga. The pictures that are represented include the West Congo Basin of Gabon, Africa. This is a tropical rainforest in Western Africa. That's in the top photo that's being presented right here. This middle picture is in Rhode Island. It's a picture of how the leaves change colors during the fall season of the year. And then the bottom picture is Malheur National Forest in the Strawberry Mountain Wilderness in Oregon. Another beautiful area to visit if you get the opportunity. So, mountains play an important role in terms of the ecosystem. Mountains are steep or high elevation lands where there's dramatic change in altitude and slope and climate, soil, and vegetation. So this takes place over a very short distance as a result of elevation change. The mountains do play a critical role in the hydrologic cycle because they serve as a major storehouse of water. Most of the world's population depends on mountains for fresh water. In fact, about 1.2 billion people live in mountain ranges or in their foothills. And about 4 billion people, 57% of the world's population, depend on mountain systems for all or some of their water. So mountains can actually be islands of biodiversity that are surrounded by areas of less diversity. And they often have endemic species found nowhere else on Earth. So they definitely have a unique role in the ecosystem. And finally, the last item on the slide is a little bit tough to read, but mountains also help regulate climate. They can reflect sunlight because of their ice-covered, snow-capped mountains. When the snow melts and the rock is exposed, they can absorb the heat and create what is known as rain shadows. So mountains do have an impact on climate. So this slide depicts some major human impacts on terrestrial ecosystems. Remember, we said that biomes are deserts, grasslands, forests, and mountains play a unique role. They're not really a biome, but they're a topographic feature that has impact on climate. So let's take a look at some of these human impacts on terrestrial ecosystems. On average, about 60% of the world's major land ecosystems are being degraded or unused or used unsustainably. And this is occurring as the human ecological footprints get bigger and bigger. So, some examples of how we're impacting deserts. Well, large cities located in a desert are going to have a withdrawal on the local groundwater system and can result in over-extraction of groundwater. So depletion of groundwater is listed under here as well. Also, some of our large desert areas, especially here in the United States, we are extracting minerals from these regions as well as natural gas and oil, and land disturbance can be associated with these types of activities. Grasslands have really good soil, and we've converted many of our grasslands to cropland. And as a result of that, we've got a habitat loss that occurs. In addition, we do livestock grazing on grasslands, and livestock can actually overgraze the grasses and create erosion problems also. In terms of forests, it's a no-brainer that clear cutting of forests is a direct impact on them. We can clear the land for agriculture, for livestock grazing, for timber, and maybe urban development. And this is probably one of the biggest impacts on forests. What ends up happening is you remove trees. Typically in the past we did clear cutting, and as a result we had high soil erosion problems occur also. And then we have the mountain region. In the mountain areas we have forests, so there's timber extraction. Also, because of the means by which the mountains formed, you can find unique minerals to extract from those areas as well. We also use mountain regions to dam up streams and rivers to create dams and reservoirs for water supply, and that can have an impact on the ecosystem as well.